All right, good afternoon, and welcome to Preferred Utilities Technical Seminar on Carbon Emission Reduction Strategies for the Boiler Room. Carbon emission reduction is a high priority for a lot of universities and municipalities that operate central steam and hot water plants. This presentation will spell out the options that are available and show you how you can estimate the carbon savings from different technologies. This portion of the webinar is pre-recorded. We recorded it yesterday. Immediately after we run this recording, we're going to go live with your questions and answers. So if you have questions at any time during this presentation, please email them to the email address on your screen right now. That's deoff@preferred-mfg.com, and we will take your questions live immediately following this presentation. We're going to start with the regulatory environment for carbon emissions reduction. 9 Northeast states signed an agreement that caps CO2 emissions to 2014 levels and mandates annual reductions until the year 2020. Sort of like clean air compliance, each state is free to come up with their own plans to achieve these goals. Connecticut has an executive order in place that requires 45% carbon emission reduction by the year 2030. Delaware has a plan that calls for 30% carbon reduction by 2030. Maine's governor released a plan to cut carbon emissions by 30% by the year 2030 as well. Maryland's General Assembly passed a bill that requires a 25% reduction in greenhouse gas emissions by the year 2020, as in next year. Massachusetts passed a law in 2008 that requires 25% carbon emissions reduction by 2020 and 80% carbon reduction by the year 2050. New Hampshire has a climate action plan that has a midterm goal of reducing carbon emissions by 20% by the year 2025. New York has an executive order with the goal of reducing greenhouse gas emissions by 40% by 2030 and 80% by 2050. New York has a long way to go. In 2018, New York generated just 4% of its electricity from renewable sources. Rhode Island passed 2 bills that require carbon emissions reduction of 80% by 2050 with interim goals for 2025, 2035, and 2045. Vermont's bill requires 75% greenhouse gas emission reduction by the year 2050. While these greenhouse gas reduction targets seem optimistic at the state level, they are attainable at the individual central plant level. Technologies exist today to reduce greenhouse gas emissions in modern boiler rooms by at least 80 to 90%. So an overview of the strategies we're going to talk about. The first thing we'll discuss is increasing fuel efficiency. Any reduction in fuel burned is a comparable reduction in carbon emissions. Also, you can add variable speed drives to boilers to decrease electrical consumption. And we're going to show you how you calculate carbon reduction based on electrical consumption reduction. We're going to talk about fuel switching from one fossil fuel to another. And then finally, we're going to talk about fuel switching from a fossil fuel to a renewable fuel, which will yield by far the most carbon reduction. So we're going to start small and end big, beginning with fuel efficiency improvements in the boiler room. You can indirectly decrease the carbon emissions from your boiler plant by reducing the electrical consumption of the plant by installing variable speed drives on your bigger motors. This includes burner forced draft fans, induced draft fans, and feedwater pumps. To convert from kilowatt hours saved to CO2 not generated, you can use the EPA's AVERT calculation. Nationally, the conversion is 7.07 times 10 to the negative fourth tons of CO2 per kilowatt hour. Regionally, that number can be different depending on the mix of generating equipment in each of the different parts of the country. So for example, that number is going to be higher in Texas, where we get a lot of our electricity from coal still, and it's going to be much lower in, say, the Pacific Northwest, where they have a lot of hydroelectric energy. This chart has boiler or fan load on the x-axis and fan horsepower or kilowatt hours on the y-axis. The top line shows a typical fan horsepower curve without a VFD and damper control of the airflow. We call it driving with your foot on the gas and your foot on the brake at the same time, so horsepower reduction at lower loads is limited. With VFD control, we slow down the FD fan and run on the lower curve. The vertical distance between the two curves is your horsepower savings. This is the formula for fan horsepower versus speed out of the little Buffalo Fan Bible. Typical burners are set up for about 20 hertz fan speed at low fire. Preferred burners can go a little lower. We typically set up our burners for 12 to 15 hertz at low fire. Even at 20 hertz, the electrical savings compared to 60 hertz is 96.3%. So for boilers that don't run hard, especially in the summer, that's typical of a lot of boilers, you can reduce your electrical consumption a bunch by slowing down your FD fan. To estimate the fuel and electrical efficiency gains possible with a burner and controls retrofit, you can use Preferred's online energy saver payback tool. You input the excess air, stack temperature, and load profile of your existing burner, as well as the performance of the proposed new burner, and the web app estimates your fuel, electricity, and carbon savings. You can input your fuel, electricity, and retrofit costs, and the web app will output an ROI for the upgrade. The web app doesn't calculate the CO2 savings from the electricity reduction yet. Our programmers are busy people working on other projects, but they're going to get to it. In the meantime, you can use the AVERT calculation, or you can use the national average of 7.07 times 10 to the negative fourth tons of CO2 per kilowatt hour reduced. Electrical savings from a VFD are more pronounced in boilers that run at low fire a lot. This makes sense. If you ran at high fire all the time, you wouldn't need a VFD. However, burner engineers are always conditioned to always round up so that they don't undersize a combustion air fan. As a result, most combustion air fans are oversized. If you look closely at the damper blades on existing burners, they may only be open 45 degrees at high fire. When you retrofit these burners with an FD fan VFD, you often find you only need about 50 hertz or so to reach high fire. That means that even at high fire, you're going to see some electrical savings by adding a variable speed drive. The same math applies to induced draft fans, but they are less common. Many plants are putting VFDs on their feedwater pumps now too. Next topic, fuel switching from a more carbon-intensive fuel to a less carbon-intensive fuel. This is part of the reason for the war on coal. Below are CO2 emission rates for the most common fossil fuels. This is based on the stoichiometry of burning different fuels. If you still remember your high school chemistry and balancing chemical equations, you can check these numbers. You can take these numbers and make a little chart to estimate the change in carbon emissions changing from one fuel to another. For example, if you switch from number 2 oil to natural gas, your carbon emissions reduction will be about 28%. And the way I did this table, positive numbers are an increase in carbon and negative numbers are a decrease in carbon. So if you see on the top row there, switching from natural gas to anything else, you get a positive number, so you actually generate more carbon. All utility plant boilers can be converted to natural gas firing. These boilers can have as many as 48 burners per boiler, but the good news is you can typically keep the existing fans, wind boxes, and burner registers. The existing burners can be fitted with gas injectors to burn natural gas. Getting the gas to all these burners on multiple firing decks requires a lot of valving and piping. And this has really been the method that we've reduced carbon emissions for the last 10 years in this country, is by replacing coal with natural gas. Spreader Stoker-fired boilers are more difficult to retrofit to gas. The process typically involves removing the traveling grate, sealing the furnace bottom with a new refractory floor, and adding wall-fired burners. Existing blowers may be able to be reused. To convert to gas in a central steam plant with packaged boilers, in most cases the burners are going to have to be completely replaced. Gun-style burners for fire tube boilers and windbox burners for water tube boilers can all be replaced. Even Cleaver-Brooks boilers, with burners integral to the front wall of the boiler, can be replaced with preferred burner inserts. Burner retrofits are tricky to do right. You need a knowledgeable burner/controls vendor and a representative from the plant to decide piece by piece which of the existing boiler plant components can stay and which need to be replaced to achieve the goals of the burner replacement. This includes the windbox burner fan assembly, the flame safeguard, and fuel-air ratio controls. It includes existing instrumentation like pressure and flow transmitters and motor starters or VFDs. Why spend money replacing perfectly good equipment if it will work with a new burner? Recall, the pressure is on to reduce greenhouse gas emissions by 50 to 80%. So how much have we achieved so far with the technologies we've discussed? Switching from number 2 oil to natural gas will gain you about 28%. If you install a high-performance burner, you can get about an additional 8%. This really depends upon the excess air performance of your existing burner. Back in the 70s, during the first fuel shock, American companies developed very low excess air burners to reduce fuel consumption in boilers. During the 1990s, the emphasis was on low NOx, and low excess air performance was sacrificed in most burners. It's gotten even worse with ultra low NOx burners. The mesh head type burners typically run 20 to 25% excess air, whereas back in the 70s, they were able to do 5 to 8% excess air. So a lot of times when I look at the burners on existing boilers, we find that if the burners are 1990s, 2000 era, we can reduce the excess air by quite a bit. Sometimes if they're 1970s era, they're running as low excess air as we can do today. They just couldn't do low NOx in those days. So with excess air performance, sometimes older is better. It just depends. And that 1970s, 1980s era is the sweet spot. Finally, you can add an FD fan VFD, and depending on the load profile of the boiler, how much that boiler turns down, you can reduce your carbon emissions by about 6%. So you add all these up, you get about 42%. And 42% is not the 50% that was the target of most of these Northeast states. So finally, the last thing we're going to talk about is fuel switching from fossil to renewable fuels. And this can yield by far the most carbon reduction. And ironically, a lot of times it doesn't involve new burners or controls. It depends on what's there. And we'll talk about that in more detail. Everybody in the industry is familiar with landfill gas and digester gas. Both are renewable fuels made from renewable sources. We've been burning these fuels since at least the 1980s. The problem is they are gaseous fuels that can't be economically transported any distance. And even if you had the real estate to put in a lagoon or a digester in the middle of your campus, you're not going to want to do it. They smell really bad. So we see these at landfills, of course, and we see them at wastewater treatment plants. And the technology has been there to burn these fuels since at least the 1980s, maybe farther. I entered this industry in 1990, and we were doing digester gas and landfill gas retrofit projects then. And they're relatively easy. Good practice is to make everything out of stainless steel because there's typically H2S in digester gas and landfill gas, and that converts to SO2 when you burn it, which can convert to sulfuric acid in the presence of moisture. So we always wanted our fuel trains to be stainless steel. You can also do a biomass project where you're burning wood chips or some sort of solid renewable fuel. And again, the same transportation costs apply. Solid fuels are difficult to transport and they're difficult to handle. And you have the added difficulty of you get batches of dry biomass and then batches of wet biomass that can make combustion difficult. The boilers for solid fuel firing are typically more expensive than a typical packaged boiler. So it involves usually a pretty high capital cost to burn something like wood chips. Preferred works with two companies that produce liquid biofuels that can be put on a rail car or put on a truck and delivered directly to your facility. This unphotoshopped picture is proof. The first company we began working with is a company called Emission. They make a renewable fuel called Renewable Fuel Oil, or Rfo for short. It's made from tree trimmings from harvest residues or commercial tree plantation thinnings. If this biomass wasn't made into Rfo, it would be burned or left to decompose, and the CO2 would have hit the atmosphere soon anyway. So the CO2 that you create from burning Rfo doesn't count towards greenhouse gas emissions like the CO2 from burning fossil fuels. Rfo has been approved for all regulatory credits for renewable fuels, including RINs, LCFs, cap and trade allowance credits, and RECs, or RECs. This is a very simple diagram explaining where Rfo comes from. The end products are liquid smoke that's sold at the grocery store, renewable feedstock sold to petroleum refineries, and Rfo for steam and hot water plants. By the way, when you burn Rfo in your boiler, it does produce a very nice wood smoke aroma. Because Rfo is biogenic, greenhouse gas emissions from Rfo are about 88% lower than with number 2 oil and 82% lower than burning natural gas. It's not 100% because it takes some fossil fuel to make renewable fuel oil and transport it to the job site. And Preferred can convert virtually any fire tube or water tube boiler over to burn Rfo. The main thing to consider with Rfo is that it's acidic, so everything in contact with it must be made out of stainless steel. Emission typically amortizes the cost of the fuel conversion in a 5-year fuel contract. Even with the fuel switching costs, the price of Rfo is close to the price of natural gas on a BTU basis, or even below. The price depends a little bit on the logistics of getting the fuel to your plant. If you have rail access, that's ideal. If they have to truck the fuel from their local processing plant, the cost can be slightly higher. But the fuel price of Rfo is very, very competitive. Preferred has converted fossil fuel fired boilers to Rfo at Bates College, where we've actually done 2 boilers. And the Bates College, those were Cleaver-Brooks fire tube boilers. We converted water tube boilers at Youngstown Thermal, and we supplied a new Williams & Davis boiler with preferred burner for the CNRC in Ontario, Canada. So Bates College has converted 2 of their central steam plant boilers to RFO. As soon as our technicians finish tuning up their new burners, Bates issues a press release touting their success reducing greenhouse gas emissions at their campus. You can follow the URLs here, or you can Google the word Bates and Renewable, and you'll find these articles. I recently Googled Bates carbon reduction, and I found that Bates College announced in May this year that their campus is now carbon neutral, in large part to converting these 2 boilers at their central plant to RFO. The other renewable fuel Preferred works with is Bio Residual Oil made by the Renewable Energy Group, or REG, out of Ames, Iowa. And on the screen now are the properties of Bio Residual Oil in a comparison to number 6 oil. Viscosity is less than number 6 oil. Sulfur is much, much less than number 6 oil. Nitrogen is much less. Ash content is much less. The fuel is virtually dry at 0.15% moisture. And you can see the carbon-hydrogen ratio there. Bioresidual oil is a byproduct of biodiesel production, ethanol production, and includes recycled cooking oil. Bioresidual oil has a very low carbon intensity. Not only is it made from renewable sources, it is also something of a waste product from other processes. So most of the carbon produced manufacturing bioresidual oil is attributed to the biodiesel and ethanol that it's produced from. And this chart shows this is mostly the process of making biodiesel. And then you can see at the very end, there's a distillation process that goes on, and they separate biodiesel from bioresidual oil. So bioresidual oil is made up of mostly heavier components that they don't want in their biodiesel. And these heavier components will burn just fine in your boiler. And the fuel is actually very, very clean. So REG is the largest supplier of biodiesel in North America. They generate about 649 millions of gallons of fuel sold every year, and that amounts to about $2.4 billion in revenue every year. Bioresidual oil is currently produced in 5 REG plants located in Minnesota, Iowa, and Illinois. Because REG is North America's largest supplier of biodiesel, they have a very large infrastructure for getting biodiesel to their customers. They have terminals around the country, and they are experts at getting fuel from their refineries to customers throughout the United States. By California's LCFS methodology, bioresidual oil produces about 5 grams of CO2 per megajoule. That's 20 times lower than number 2 oil and 16 times lower than natural gas. Bioresidual oil is non-toxic, non-flammable, and non-hazardous. Preferred started burning biodiesel residual oil in our 2 shop boilers in June last year. The burner on the left is a 1950s vintage Preferred rotary cup burner designed to fire number 6 oil. The burner on the right is our state-of-the-art low-emissions Ranger burner. They are both burning bioresidual oil. Bioresidual oil has the appearance, viscosity, and odor of used French fry oil. Think French fry oil that you never ever change. I think of it as French fry oil, but it's actually much cleaner than used cooking oil because of the steps REG takes to remove contaminants from the fuel. It has virtually no ash and no water, and unlike petroleum-based fuels, it contains no heavy metals. This is the startup data from one of the two boilers in our plant that our combustion engineer Dan Wallace converted to bio residual oil. Important things to note include we heated the bio residual oil to about 160 to 165 degrees. If existing burners are using number 6 oil or number 4 oil, they will have a pump and heater set that could be reused. And number 6, back in the old days, we would heat number 6 to about 210, 220 degrees to get it to the viscosity that we needed to atomize it. When low sulfur number 6 became common, that temperature dropped to 180 or 190. So any plant that still has their infrastructure to burn number 6 oil should be reusable for bioresidual oil. Our two boilers were set up for number 6. We still had the pump and heater sets installed, but they had actually been burning number 2 for the past few years. So combustion efficiency is similar to number 2 oil. Stack CO was less than 10 parts per million. This is considered clean combustion for any fuel. Opacity was 0 throughout the boiler load. And NOx was about 163, which puts it at less than number 6 oil and more than most number 2 oil. So the key results, we had to heat the fuel to about 162 degrees. CO emissions and capacity indicated clean combustion. Excess air levels were comparable to number 2 oil, and boiler efficiency is about the same as number 2 oil. Preferred's been firing bioresidual oil all through the 2018-2009 heating season with no downtime. We shut these boilers down for the summer. We opened them up, inspected them, and found no unusual ash or other deposits in our boilers. When they were fired up again a couple of weeks ago, we had to clean a strainer and we had to circulate some oil to clean out the metering assembly. Then the boilers fired right back up. So if we add all this up, by switching your boiler from fossil fuel to either RFO or bioresidual oil, you'll decrease your carbon emissions by 82 to 90%. If you install a high-performance burner in addition, you can pick up another 2%. If you add an FD fan, VFD, you can get another 6%. So in total, you can reduce the carbon emissions at your boiler plant by 90 to 98%. And the amazing thing is you can decrease your carbon emissions just by switching to renewable fuel, and you may not have to replace your burner or controls. When Dan switched our two boilers over to bioresidual oil last June, we didn't replace anything. All he really did was give our boilers a tune-up with the new fuel. So the three things you really need to burn these fuels is you're going to need a pump and heater system. If the plant is already burning number 2 oil only, they're not going to have trim heaters, so we would have to add a heater to their system, and that heater can either be electric or steam. They need a fairly modern burner that's designed to burn a liquid fuel, and then because the viscosity of these fuels can change a little bit from batch to batch, you're going to need oxygen trim to make up the difference. Our two boilers both have oxygen trim, and we see the oxygen trim working a little bit to stay on the O2 set point. So the price of RFO is comparable to natural gas or could be lower. The price of bioresidual oil is a little bit less than number 2 oil and could be significantly less if you have rail access to your plant. So people have the idea, I think, from shopping at Whole Foods that going green means spending more. In the case of these renewable fuels, both of these fuels are less expensive than number 2 oil and give you very significant carbon reduction. So if you're interested in burning renewable fuel in your boiler plant, a preferred technician will come out to your plant and evaluate your existing boilers, burners, and controls. and then we'll present you your fuel options, including capital costs and fuel costs, and let you make an informed decision. When you decide to switch to a renewable fuel, you will enter a contract with the fuel supplier directly. Preferred will come out and install or supervise the installation of any new equipment required, and then Preferred technicians will start up the new equipment and retune your boilers as necessary. We'll train your operators what to expect with the new fuel, and then Preferred technicians will be available on site if you have a fuel-related problem. Our goal is to only switch customers to one of these renewable fuels for customers that are within close driving distance of one of our technicians. And we have technicians spread out throughout the country. We're especially strong in the Northeast and upstate New York, where we see most of these renewable fuel candidates are going to be. So for next time we'll do a deep dive into some of our fossil fuel to renewable fuel retrofit projects, and we'll cover a typical site survey and what to look for when evaluating a renewable fuel boiler retrofit. So now we're going to switch over and go live, just like live PD, and we're going to take your email questions.